Okay, so in this video, I'm just going to introduce linked lists. This should be review for a lot of you. I think all the classes that funnel into this class go over linked lists, but it's nice to refresh our memories on what are the components of a linked list. So a linked list is a data structure that stores a sequence of elements. What's different from a linked list versus an array is that each element is stored separately, so you can't guarantee that the memory is contiguous or next to each other. So in order to make sure that the sequence is connected, you chain them together into a sequence, and then you have to mark the end of the sequence in some way so you know when you have reached the end. And you do that by using a null pointer. So that's the overall idea of the linked lists. Before we get started, I just want to emphasize this, and we're going to tell you this pretty much anytime you ask us for help on your class that you're writing for the link structure. You cannot implement a linked list without drawing it. So you should have next to your computer a whole stack of papers, a whole notebook, and even different colors really helps. And you should be drawing constantly. You should draw before you start programming. You should draw before you run your code to trace it out. You should draw when you have a bug. You can write out a whole implementation using a link structure, and it will completely not work at all because you have, one connection that was incorrect. And the only way to find it is to draw. Definitely some tools like GDB helps, and I've shown you some resources on how to use GDB, and I'll do that here at the end of this week's lecture as well. But it can only take you so far. Your logic and the concept of your code has to be pretty correct first before that can really help you too much. So when you come in to get help with your code, we're going to want to see your drawings or your diagrams of what you expect the code to be doing or what you intended for it to do and where you're seeing that it breaks. So the other big part about a linked list, and this should be review, is this part I'm talking about, is that you use a struct, which is usually called like a node or a cell or something of that nature. And the struct is a node that stores whatever information you want it to store. So in the case of the simple linked list, it's just going to store one value, which is a string, and then it's going to have a second member variable that's a pointer to the next node that it's connected to. So here is an example of what that might look like for a single node. So you have a node, it has the string hi in it, and then it has a pointer that points to like the next node, which can be a whole list of nodes, right? And this is just a quick example of what this node looks like. Here's a little example of how you build a link structure just by writing all the code in main and not building any class into it, just as a little bit of review. So let's go line by line on this. So the first line here is allocating memory for a new struct. All of the nodes that you create in your class are going to need to be dynamically allocated on the heap, so that they stay in scope, throughout the lifespan of the object. So here we're creating a node, a star, so it's a pointer to a node, and we're calling it list, and then we're allocating memory for that node and pointing that list pointer to the data that we just allocated. So what one does is it's basically just allocating the space here. It's creating this pointer list, and then it's linking the list pointer to the struct that we just allocated. Now when you move on to 2 is going to fill in the value inside of that struct that we just allocated. Number 3 here is going to allocate space for a second node, and then it's also, because it's linking it here, it's linking the old lists next to the node that we just created. And then here on step 4, we're taking we go from list to next to value, and so it's going to be putting in the value b exclamation into the node struct that we just created. And then we're doing it a third time, so 5 is going to be going and adding a third node, and here we're going through 3 pointers, so going from list to next, and then that gets us to link the second node to the third node that we just created. Then line 6 is going to fill in the value, and then line 7 is going to link the last node to a null pointer. This is actually a very important step and is often forgotten. If you don't end your linked list, and if it's a doubly linked list, you have to do this on both ends, then any of the code that you're writing that walks through the list until you hit null is gonna crash, right? So whatever you do, make sure that you end your linked list with a null pointer. It's kind of a crucial component of the linked list. Now, you're not going to write any code like this in any of your classes, right? But this just is getting us familiar with how linked lists work, how they link together, etc. So I'm going to show you lots of examples of how you actually build a link structure in a function within a class. A couple things that you have to really think about carefully when you're writing linked lists is changing the list at all. So if you are adding to the list or removing from the list, you have to think about all the cases. And this is the trickiest part about writing a linked list class, is that there are a lot of edge cases. And like I said, you cannot write the code for these classes unless you diagram them. So here's an example of 3 cases that you have to consider anytime you're adding something into your linked list. So if you're adding something in, it's different when you're at the front, when you're at the back, and when you're in the middle. And so when you add those, you have to rewire your linked list each time. So if you're at the front, you're going to have to update the head node, and you're going to have to link that newly allocated node to the front of the linked list. That's a slightly different code or consideration than to the end. To the end, you just need to go to the last one and link the new node to the end. And then, and sometimes this doesn't require a special case, and sometimes it does. So you just have to think about it and test it out. And then adding to the middle, you're going to have to go and find, the 2 nodes that you're going to insert in between, and you need to create that new node and then, rewire those pointers so that they connect properly. One of the things that is tricky with inserts or adds is what is the insert function? Are you inserting always at the front? Are you inserting always at the back? Are you inserting at some I location? Are you looking for some value in inserting? Linked list structures could have any of these behaviors or functions associated with them. So you want to pay attention to that, because not all inserts are the same. Remove is similar. You have these 3 cases that you are going to want to be careful to consider. If you remove the front, the middle, or the end, they're very different cases. You also have to be careful with remove, because remove requires a deallocation. Unlike a C array, which we just keep track of capacity and size, and we just kind of shift stuff around, when you have a linked list, anytime you take away a node, you actually have to deallocate that memory. You don't reuse it. And so those are the 3 cases with remove, and they're basically the same considerations with insert, except for instead of relinking to a new node, you're relinking the existing nodes from what you removed. And you have to do all of this in the proper order because you can't delete something before you get what you need from it, right? So those are some of the things that we're going to go over in the different functions that we're going to work through in this week's lecture. So how this week's lectures are formatted is I'm going to go through 5 different functions of a linked list. They're pretty much all of them, but you could have different variations of these. But we're going to traverse a linked list. That's the easiest one, so we're going to do that one first. We have to be able to build a linked list, so we'll do that one second. We have to be able to clear out a linked list entirely to deallocate all the memory for it. And then we're going to do a version of insert and remove, where you're just inserting and remove a single element. So those will give you a good example of all the different types of things that you do with a linked list that you can use to base your own class off of. A couple things I'm going to show you, because I think a lot of you have done this before outside of a class, like you've just written linked list codes in main. I'm going to first show you the code to do it just inside main, and then I'm going to show you what changes when you move it into an actual implementation of a class. So throughout the rest of these slides, this is the class that we're going to be creating. It's a linked list class. It has this private struct that we've been talking about that we're going to use as our nodes to build the linked list, and then just 2 private member variables that keep track of size and keep track of the front of the linked list, which you always need to have in a linked list class. You have to know which one is the beginning, right? Because you're not passing those around. Those are something that just needs to be saved. Okay, so that's it for this one. Thanks so much.